Water freezes at 0 degrees, but so it does it with salt in it? Welcome to Teclen Lyophilization Knowledge Hub. In this second video, we are going to be talking about the freezing step of a lyophilization process. Water freezes at 0 degrees, but it's common knowledge that if we add salt in it, the freezing point decreases. This is the reason why we are using salts on roads in cold regions at winter for avoiding freezing. So solutes are modifying the phase change properties of the dissolutions. But then why freeze-drying scientists are relying in water diagrams and related tabulated data? Can we rely on pure water properties for freeze-drying? Let's see the following video. We can see some vials in a freeze dryer with a sucrose dissolution in it, and then we are cooling down. The temperature goes below 0, and after some time, suddenly ice forms, occupying the whole vial volume. But not only that, the product temperature also goes up to 0 degrees. What just has happened? What is this really sudden process? And more importantly, what all of this has to be with the initial question, can we rely on water properties for freeze drying? The answers to these questions are paramount for understanding the main step in freeze drying, the primary drying. I am going to give you some seconds now, you can pause the video, because afterwards I'm going to reveal the secrets of it. The answer is that we can totally rely in the phase change properties of pure water in freeze drying. This is because the solute concentration is very low. And then what happens is that when we are below 0 degrees, pure ice crystals start to form and grow, concentrating the remaining dissolution that at the end also solidifies. And then the crucial consequence of it is that even if we start with an homogeneous dissolution in liquid state, we end with an heterogeneous solid, composed mainly by pure ice surrounding the concentrated dissolution, also solidified. And then, for the temperature spike, I need to go to the physics of this phenomenon. Here, we can see a trend temperature time representing the temperature of the fluid in red and the temperature of the product in green. We start at 20 degrees and then we start to cool down, for example, to minus 60, and then we can see that the product is being cooled down below 0 degrees. What is happening below 0 degrees is that we have water in an unstable form. It's storing cooling energy in form of sensible heat. All this stored energy in form of sensible heat between the temperature of stable fusion of water pure ice and the supercooling temperature is going to be suddenly released up to a point, for example, minus 40 degrees, in what is called the subcooling temperature, that all this energy is released for the phase change, for solidifying the water up to 0 degrees. So all the sensible heat stored is providing for the phase change. Afterwards, reaching 0 degrees, the freezing process continues, freezing the remaining ice and then solidifying the concentrated dissolution. Freeze drying is a complex process with different crucial steps. For being able to develop lyophilization cycles by knowing and diagnosing freeze drying trends, it is important to have a good balance between technical and scientific skills. It is always advised to make use of the best equipment and tools. At Teclen, we provide solutions with protective membranes, as our stainless steel tray. Once the product is poured inside it, there is no risk of spillages during the loading and unloading of the freeze dryer, neither risk of contaminants going in, but also during the freeze drying process, no product is going out by fly out. If you want to learn more about freeze drying and about how Teclen products can help you with it, please do not miss the following video of the Teclen Lyophilization Knowledge Hub.